Here we have a question on gravitation. Let's take a look. The diagram below illustrates the planet Saturn with a combined diameter of 2.72 into 10 to the power of 8 meter. Saturn has several rings, each of which consists of many small particles that orbit the planet. Saturn may be considered to be a sphere with its mass capital M concentrated at its center. Here we understand that the planet Saturn is considered as a point mass with its entire mass concentrated at the center. Deduce that for a particle in one ring moving in a circular orbit of radius capital R, the linear speed v of the particle in its orbit is given by the expression capital G times capital M is equal to capital R into v squared. To deduce the answer for part A of this question, we need to have a prerequisite. The prerequisite as follows. We will understand that the particle here has a mass small m and it is at a distance of capital R from the center of the planet, that is Saturn. We understand that the gravitational force of attraction Fg between the mass small m and the planet Saturn is given by the formula F gravitational is equal to capital G into m1 into m2 divided by the square of the distance between them, giving us G capital M small m by R square. We understand that the force is attractive in nature, which means for the body of mass small m, the gravitational force is directed towards the center. For a body in circular motion, we understand that the centripetal force is given by the formula m v square over capital R, where v is the velocity of the particle in circular motion. We understand that centripetal force is a force that is directed towards the center, and in this specific case, the gravitational force acts as the centripetal force, keeping the body of mass small m in circular motion. Hence, we equate gravitational force to centripetal force, and simplifying further, we get the relationship capital G into capital M is equivalent to capital R into V square. This also helps us understand that since capital G and capital M are constants, R into V square is also a constant. Let us move on to part B. Part B of the question is a numerical. One ring, the A ring, has an outer diameter of 2.72 into 10 to the power of 8 meter. This helps us find the radius R as half of that, half into 2.72 into 10 to the power of 8 meter. We have the mass of the planet given as capital M is equivalent to 5.69 into 10 to the power of 26 kilogram. A particle orbits on the outer edge of this ring. Determine the time for the particle to complete one orbit of Saturn. Here they are asking us to calculate the time period of orbit, capital T. To find the value of capital T, we are in need of two equations. The first equation will help us find the value of V, which is already given as capital G into capital M is equal to capital R into V square. Here the value of capital G is obtained from the data booklet as capital G is equal to 6.67 into 10 to the power of minus 11 Newton meter square per kilogram square. Using this, substituting the values of for R, M and G, we get velocity V to be 1.67 into 10 to the power of 4 meter per second. We also have an equation that relates to capital T, V and R as V is equal to 2 pi R divided by T. Using this equation and making capital T time period as the subject of the equation, we find the value of time period T to be approximately 5.1 into 10 to the power of 4 second. We also have approximated the answer to two significant figures. Moving ahead, another particle of mass m is orbiting at a distance r from the center of Saturn. State a formula in terms of G, M, and R for gravitational potential energy EP. The gravitational potential energy EP is given by the formula EP is equal to negative G test mass, that is small m, into source mass, that is capital M, over the distance r. Moving ahead, the gravitational potential energy of this particle decreases. Suggest and explain the change, if any, in the linear speed of the particle. Here, to find out the status of linear speed, we will first look at distance r. We know that gravitational potential energy is related to r as EP proportional to negative 1 by r. If this were a positive sign, the decrease in gravitational potential energy would increase the value of r. But because of the negative sign, we understand that if gravitational potential energy decreases, r also decreases. But we also understand from part A of the question that r into v square is a constant, as stated here, which means if the value of r decreases while r into v square is a constant, the value of linear speed v must increase. Moving ahead, we need to explain the concept of escape speed. We define escape speed as the value of speed that any test mass needs to have or needs to possess on the surface of a planet such that it can move an infinite distance from the planet, or in other words, it can escape the gravitational pull of the planet.